Because of AI, it is now possible to obtain enough evidence through a very large data set, which can help us to better understand the origin and early evolution of animals on this planet. I have been working on the origin and early evolution of animals during the past 10 years. This question is quite important for us, actually, because human beings are animals, right? We want to know who we are and where we are from. When we ask these questions, we find ourselves asking for the first animals, where the first animals from, and how they lived on the early ages. Due to the vast territory of China, it preserves a lot of very important fossil sites. For example, the 𝗠cie𝗿𝗶𝗹𝘀, dating back to 520 million years ago, it preserves a large number of soft-bodied animals from the early Cambrian. And another example is 𝗶ሔር𝗵𝗹𝗀, dating back to the dinosaur era. It yielded a lot of dinosaurs and birds fossils. So the paleontological discoveries in China can bridge some knowledge gap in this discipline. That's why we say the paleontological research in China is important globally. Yeah. As a paleontologist, we have to go outside, go to the field of collecting fossils, right? The early animals are soft, tiny, no more than 1 millimeter in size. We needed to know the internal structures of the tiny specimens to know what are them, right? Because these microscopic specimens are quite small and looks very simple on the surface. So if we just use SEM to observe the surface structure, it's not enough for us to reveal the biological affinity of these specimens. Conventionally, we use making thin section to reveal the internal structure, but it's a destructive method. So now we apply the micro-CT scan to reconstruct the internal structures. When we use the high-resolution micro-CT, for example, one specimen will take us about 5 to 6 hours to finish the scan. We have hundreds and thousands of specimens to scan. So the challenge is efficiency. It was about 3 years ago, I realized that maybe the AI deep learning can help us to reduce scanning time and the data processing time. So I get contact with the engineer from Zeiss, and we discussed the potential. I sent her some data I scanned before, and she just did the demo reconstruction for us. When I see the image on the screen, wow, that moment, it is definitely the wow moment for me to see the result. She only used 400 projections to produce the final volume data with the same quality from 3,000 projections. So that means we can reduce the scanning time from 5 to 6 hours into 40 or 30 minutes. It's really helpful. Several years ago, we have found a very tiny specimen. It was around 600 million years old. That specimen is a sponge-like thing, very tiny, no more than 2 millimeter. But it preserved very, very good cellular structures. It's very rare. It's hard to find soft-bodied specimens consisting of all the cells inside, right? We scanned it using synchrotron and also micro-CT. We realized that it was the very first sponge on this planet. Sponge actually is quite simple, right? But it's quite important for us to know the origin of animals because it's the first animal diversified from the common ancestor of all the animals. It happened maybe 600 million years ago, but nobody knows the morphology and reproductive process of the first animal, right? So we needed to trace the first animals in the first record. This sponge-like specimen is quite near, is quite close to the first animals on this planet. So it provides us very important diversification point for us to reconstruction the early evolution of animals. So the main benefits of using AI for us is that we can let the machine to take over all the time-consuming work, and we scientists can spend more time in the data interpretation, and we can concentrate on the science itself. We don't have to spend many time in data collecting or data preparation. We can scan more and more specimens in a very short time.